So after the last lesson, you may be able to prove that an extreme value exists. Here we're going to find them. And you already know how to do this more or less. The new addition is we're looking on closed intervals, right? So we're no longer looking for a minimum or a maximum on the entire function. We just want to know about this particular interval from -1 to 3. So review from 1.3 is that extreme values happen where the derivative is equal to 0, right? Because that is a horizontal tangent line. Okay? And these points where the derivative is equal to 0 are called critical points. Okay, so this is our review from 1.3. So the first step to all of these problems is going to be to find the derivative, and they're all power rule problems, so finding the derivative is easy. You multiply by the exponent, then subtract 1 from it, then the derivative of the constant is 0. So that's my derivative, and then I'm going to set it equal to 0 to find my critical points. And then these I want to solve by factoring usually, so 4x factors out, and I'm left with x squared, and it's a -4x, so -4, and then this now is a difference of squares, x plus 2, x minus 2. So now I have 3 results. My first factor gives x equals 0, x equals -2, and x equals 2. So these are my critical points. And notice these all, except for my middle one, fall in my interval here. Okay, so I'm going to exclude x equals -2 because it's not in this interval. So if I'm looking for the maximum in this specific area, or the minimum for that matter, this point does not matter to me because it's not where I'm looking. Oh, and this is a -1, isn't it? So what I'm going to do here is I'm going to make a table of all of the x's it could be. So we know that our maximum is what we're looking for. Our maximum has to occur at x equals 0 or 2. But we're also going to check the endpoints. So we're going to include in this table -1 and 3. The reason for that is that my graph could look like this. So if this is -1 and 3, it could be that the maximum is one of the endpoints like this, or it could be that there is a point where the derivative is equal to 0 in the middle. That is the highest point. So we're checking each of these cases by checking all 4 of these x's. So again, these -1 and 3 came from my interval, and then these are my critical points. And then I'm going to do something that you're very, very good at. I'm going to plug these all into f of x. I'll go back up, make sure I have my f of x. Oh, that's not right at all, is it? Okay, so I'm going to plug these in. I'm just going to do it on my calculator. You guys are very good at this by now. I'll show you the results. You can check me if you don't believe me, which is always a good move. So here is what I got by plugging in these values. And then obviously, the maximum value of the function is 10 on this particular interval, and this occurs at x equals 2. Okay. So we'll say just the maximum is 10. If I had asked you for the minimum for this problem, on this particular interval, we'd look for the smallest value, right? So that would be -15. At x equals 3. Okay, so to summarize what we're checking here, we're going to make a table. And if you're organized with this in your work, this will be easy to figure out. Okay, you're going to make a table, and you're going to look for the biggest or smallest, depending on whether I ask you maximum or minimum, right? The biggest or smallest y value. for the critical values of x, so where the derivative is equal to 0, and the endpoints of your interval. So those are the points that you're checking.